write x minus 5 squared as a trinomial, you could write it twice and FOIL it, or there's a shortcut. You square the first term, x times x is x squared. For the middle term, you multiply them together, then multiply by 2, because if you were FOILing it, there'd be 2 of them. So negative 5 times x is negative 5x times 2 would be negative 10x. And then you square the last term. Negative 5 times negative 5 is positive 25. Again, you can always FOIL it. But we're looking at those perfect squares today because we're going to start completing the square. So we're going to need to know that. Factor the expression x squared minus 18x plus 81. I can square root the first term. I can square root the last term. Maybe it's one of those perfect square trinomials. Wink! Square root of x squared is x. Square root of 81 is 9. It'd have to be a minus in the middle. Let's double check. If we multiply these together and multiply by 2, do we get the negative 18x? You bet! And solve x squared plus 10x minus 3 equals 0 by factoring. I'm going to guess that is a typo. I'm going to guess it was supposed to say this. Because we can't factor x squared plus 10x minus 3 equals 0 by factoring, but we can solve this. So factors of 10 that are 3 apart would be 5 and 2. So it would be x plus 5 times x minus 2. X plus 5 equals 0, so x would equal negative 5. X minus 2 would equal 0, so x equals positive 2. Again, we couldn't solve it how it originally was as factoring. So, typo. My bad. All right. We have to simplify square roots with perfect squares. Perfect squares are numbers that you can square root, and it comes out to a whole number, an integer. So, like 4 is 2 times 2. 9 is 3 times 3. 4 times 4 is 16. 25, 36, 49. Things that you can square root. So we need to figure out which one of those can make up what we see in the radical here. So 75 is 25 times 3, and 25 is a perfect square. So we're going to break it up into root 25 times root 3. The square root of 25 is 5. So it just becomes 5 root 3. We did this back in the day in Algebra 1. You all had so much fun with it. 18, you're like, okay, here, let's list our perfect squares. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. If you can kind of keep these ones at least tucked in the back of your brain, it will make all of this so much easier. Now, it goes on forever, but these are the super important ones and the most widely used ones. So 18 is 9 times 2. So root 9 times root 2. Square root of 9 is 3. 3 root 2. Now we're just taking the positive roots at the moment, but when we're actually solving equations, we're going to take the positive and negative roots. So we would say 3 root 2 and negative 3 root 2. Or you can say plus and minus 3 root 2. We'll get there. 108. Now you might not know which one of these goes into 108, but if it's even, usually I try 4 and see what we can do. So this would be 4 times 27. Right? Yeah. And the square root of 4 is 2. So you have 2 root 27. But 27 still has a perfect square in it. It's 9. So we could break it down further. 9 times 3. The square root of 9 is 3. So we need to multiply it by the 2 that was out there. Let me move down here. So 2 times 3 root 3 would come out to 6 root 3. So this would be your final answer because there are no more perfect squares in 3. Now you may have recognized earlier that 108 is 36 times 3. And 36 is a perfect square. Square root of 36 is 6. So you can get to 6 root 3 much faster if you can identify the larger perfect square. 64 is a perfect square. It's just 8. Now here's the deal. You cannot have radicals in the denominator. So they call this rationalizing the denominator. I'm going to rewrite this down here. So what you can do is you can change a fraction however you want. You can multiply by whatever number you want. But whatever you do in the numerator, you have to do in the denominator. Or whatever you do in the denominator, you have to do in the numerator. So here, the easiest way you can turn it into a perfect square is to multiply it by itself. So we can't have radicals in the denominator. So I'm going to multiply it by root 2. Because root 2 times root 2 would be root 4, and the square root of 4 is just regular 2. So it completely gets rid of the radical in the denominator. But if you do that in the denominator, you have to do it in the numerator too. So we're going to multiply the numerator by root 2. Root 7 times root 2 is root 14, and there are no perfect squares in 14. So you just leave it root 14 over 2. You can only simplify radicals with radicals and non-radicals with non-radicals. So you can't do 14 divided by 2 because 14 isn't a radical. Let me show you something. I think this is helpful. So we just said the square root of 2 times the square root of 2 is the square root of 4, which is 2, right? If you did the square root of 5 times the square root of 5, that would come out to the square root of 25, which is 5. So anytime you're doing the square root of something times the square root of that same thing, it just gets rid of the square root symbol. So the square root of 17 times the square root of 17 would just come out to regular 17. Square root of smiley face times the square root of smiley face is just smiley face. That's fun. So let's look at this one, root 18 over 6. Now this one doesn't even have a radical in the denominator, so we don't even need to worry about that. But 18 has a perfect square. It's 9 times 2. So we'd make it root 9 times root 2 over 6. The square root of 9 is 3, so we have 3 root 2 over 6. No more perfect squares, so there's one other thing you got to check for. Can you simplify numbers without radicals? 3 over 6, if you had the fraction 3/6, that would be 1/2. So it comes out to root 2 over 2. So that's a little radical review, I know. I'm a bit radical sometimes. Solving equations by using the square root property. All right, our first goal is to isolate the x squared. So in this case, 3x minus 4 equals 68. We're going to get it down to just x squared equals something. So first, like imagine it just said 3x minus 4 equals 8, a two-step equation. You would add the 4 first. 68 plus 4 is 72. And then you get rid of the 3 by dividing it. 72 divided by 3 is 24. And that's x squared. We don't want x squared, we just want regular x. So the inverse operation for squaring is square rooting. And all right. 24, we're not going to go with like the decimal 4 point blah, blah, blah. We're going to go with what's called an exact value, which is a simplified radical version. So take your perfect squares. 24 is 4 times 6. Square root of 4 is 2. So we get 2 root 6. But when you're solving the equations, you have to give the positive and negative version of that. Because the square root of 4 could be 2, but it can also be negative 2. So the way we're going to write that is x equals plus or minus 2 root 6. That shows positive 2 root 6 and negative 2 root 6. Or you can list them separately. I like that way better. X squared minus 4 equals 0. Okay? Let's get rid of the minus 4. Plus 4 plus 4. X squared equals 4. Then we get rid of the square by square rooting. And 4 is a perfect square. It's 2. But don't forget about -2. So x equals plus or minus 2. 4x squared minus 20 equals 5. Okay, we'll get rid of the minus 20 first. Plus 20 plus 20. 4x squared equals 25. And you're like, okay, let's divide by the 4. Okay, all right. Now we're going to leave this as a fraction. You can't simplify 25 over 4, so just leave it. To get rid of the x squared, we're going to square root both sides. When you square root a fraction, you're square rooting each part of the fraction. So the square root of 25 is 5, the square root of 4 is 2. So we'd have plus or minus 5 over 2. And the last one, we'll get rid of the minus 8 first. Plus 8, 2 parentheses, x minus 3 squared equals 8. Now you could totally FOIL out x minus 3 squared. It's going to be a nightmare. Let's get rid of the 2. It's 2 times that stuff, so we're going to divide it. Which would leave us with x minus 3 squared equals 8 divided by 4, 8 divided by 2 is 4. Now all this stuff is squared, so we can get rid of it by square rooting both sides. Now here's where it gets a little tough. You have to remember that there are 2 square roots of 4. There's 2 and also -2. So we're going to set up 2 equations actually. We'll set up x minus 3 equals 2 and x minus 3 equals -2. Because we still got one more step. We got to get rid of that minus 3. So we will add 3 to both sides. Let's keep it cute and colorful over here. 2 plus 3 is 5. Over here, if we add 3, -2 plus 3 gives us 1. If you take either of these values and you substitute it into the original equation, they both work. Same with here. 5 over 2 and -5 over 2, if you insert both of them into the original equation, they both work out. Where is the thing that goes to the next slide? There he is. There it is. So we're going to start introducing you to completing the square. So our goal of completing the square is to turn it into a perfect square trinomial like this, x plus 4 squared. So think about what that looks like if it was FOIL. It would be x squared plus, multiply them together, multiply by 2, 8x, and then you square the last term, 16. We're trying to turn it into this. So let's think of how we can go backwards. If I just gave you the x squared plus 8x, and I said, okay, well, what would that last term have to be for it to be a perfect square? Look at how we get 16. It's the 4 squared. Now, how could you figure out 4 if you were only given the 8 in the middle? Well, it's half of that. So you take your b, divide it by 2, and then you square it. So 8 divided by 2 squared. 8 divided by 2 is 4 squared plus 16. That's the basic idea of completing the square, which we're really going to do more of tomorrow, but let's practice some stuff. So find the value of c that makes this a perfect square trinomial. So you look at b, b is 6, so we take our b, we write all over the board, we move stuff and get frustrated that it moved. Oh, silly me. All right, we take our b, we divide it by 2, and then we will square it. So 6 divided by 2 is 3, and 3 squared would be 9. So c would have to be 9. And if that was then factored, that would factor to x plus 3 squared, right? Because it's half of 6 or the square root of 9. So that's what we're trying to do when completing the square. We're trying to turn it into a perfect square trinomial. So I got 2 more here. You take b, you divide it by 2. So here, negative 2, divide it by 2, and then we'll square it. I'm going to move down here for a second. Negative 2 divided by 2 is negative 1. And then when you square negative 1, it becomes plus 1. So that's all it's asking for here. Well, actually, no. Good, I'm glad it's not. Because then it says write it as a binomial squared. Which it's nice because we know the square root of x squared is x. I see it's going to be minus. And then whatever we got when we took b and divided it by 2, which in this case was negative 1, that would just be your other term. So it would be x minus 1 squared. Awesome. This one's a little tougher. If we take 5 divided by 2 and then square it, we'll get our last term. Now we can turn it into a perfect square right now because it's just going to be x plus 5 over 2 squared. So that's how it would be written as a binomial squared, but we need that actual number. When you square a fraction, you just square each part. 5 squared is 25, 2 squared is 4. So it gets a little tougher with the fractions, but not a problem for you guys. All right, that's it for this one.